The laws of physics are balanced on a razor's edge for life to occur. For example, if you didn't have something like gravity that pulled matter together, you would never get planets, you wouldn't get stars, you wouldn't get any complex organisms. If you didn't have the strong nuclear force, there would be nothing to hold protons and neutrons together in the nucleus. And so you wouldn't have any atoms, so no chemistry. If you didn't have the electromagnetic force, you would have no bonding between chemicals. You would have no light, and the list goes on. So you need all these sorts of fundamental principles have to be in place in order for life to occur. Wipe out one of those principles, wipe out one of those laws, no life.
Strobel learned that life also hinges on the precise strengths and relative values of many different physical constants. One example of this fine-tuning is the force of gravity.
Imagine a ruler divided up into 1-inch increments and then stretched across the entire universe, a distance of some 14 billion light years. For the purposes of illustration, the ruler represents the possible range for gravity. In other words, the setting for the strength of gravity could have been anywhere along the ruler, but it just happens to be situated in exactly the right place so that life is possible. Now, if you were to change the force of gravity by moving the setting just 1 inch compared to the entire width of the universe, the effect on life would be catastrophic.
No large-scale life forms could exist. Anything that was more than the size of a pea would be completely crushed. So you might be able to get life of a very, very primitive sort, such as bacteria, but you could never get conscious observers.
The strength of gravity is just one of at least 30 separate parameters that must be finely tuned to produce a life-sustaining universe. Another example is the cosmological constant.
The cosmological constant describes the expansion speed of space in the universe. If space expands too quickly, then the universe will spread out so quickly that material objects can't form. So you can't get stars and galaxies and planets and the types of things that we, of course, take for granted in our universe.
Physicists have determined that the cosmological constant is fine-tuned to 1 part in 100 million billion 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 billion. Such precision has been compared to traveling hundreds of miles into space, then throwing a dart at the Earth and hitting a bullseye measuring 1/trillionth of an inch in diameter, an area less than the width of a single atom.
Just consider those two parameters, gravity and the cosmological constant. Their level of fine-tuning is to a precision of 1 part in 100 million trillion, 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 trillion. I mean, that's like 1 atom in the entire known universe.
This fine-tuning is also evident at the atomic level. The strong nuclear force binds atoms together. If the strength of this force were to decrease by 1 part in 10,000 billion 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 billion, the only element left in the universe would be hydrogen. Again, chemical life would not be possible. The fine-tuning of the laws and forces of physics is so precise